Something that's been really interesting about modern neural networks is to the extent that there are just these very few ideas that people can just use over and over again in different contexts, and they work successfully in lots of different places. So I thought I'd say a little bit about doing textual question answering, which already came up briefly in the first talk. And so the idea is we've got all the knowledge of the world in Wikipedia just about, and so we'd like to be able to ask a question of Wikipedia: how many of Warsaw's inhabitants spoke Polish in 1933? And then we might go through two phases. We first of all might try and retrieve relevant documents, for which we might use regular information retrieval. And then we want to read those documents to work out the answer, which we'll take to be a subsequence of words in the document, which will be 833,000. And I just want to say a little about how we could build a document reader. So for the document reader, we have a passage and a question, and we want to find out the answer. Again, we can use the same ingredients in a quite simple way. So for the question, what we're going to do is take the question words as word embeddings. We're going to run them through a recurrent neural network forwards. It turns out it's often useful to also run through a recurrent neural network backwards, which then gives us a bio-STM model. We're going to take the final hidden states in both directions and concatenate them together, and we'll say that's our representation of the question. For the passage, we're going to start doing something similar. We're going to have word embeddings. We're going to run that through bio-STM hidden layers. But this time we're going to do something slightly different so we can pick out the subsequence of words in the passage that will be the answer to our question. So we'll again use exactly the same kind of attention, where we look for this generalized dot product to identify a start position in the span. And then we're going to also use the same calculation to generate an end position in the span. But in the generalized dot product, we've got a matrix in the middle. So we have two different matrices from start and end. And so they can specialize to pick out different information. And again, you might almost wonder, how could this possibly work? But again, if you set up an objective of wanting it to give high probability to the right answer, the whole network will self-organize so it does learn. And in particular, the LSTM sequence model over the passage will learn to convey information along its sequence model so that the sequence model contains markers of the start and the end, which can then be picked up when you're picking out the subsequence. So what we find is using deep learning in general gave much better results than previous question answering systems. Even this simple model, what? Yeah, I've seen it. This simple model gave basically state of the art in 2017. Of course, people have kept on working on it and things have gotten much better again since that. But you really can use this to ask simple questions. You can say, ask what question answering is and find it's a computer science discipline. You can ask about baseball people that you want to know about, and that works. And you can get the answers to the answer to life, the universe, and everything. It really works